All right, and we are back ready to do AC simulation. So we've designed an inverting amplifier using an op amp. We have simulated it in Multisim, showing the DC, make sure that we can get the gain right now. The last episode to do the AC simulation, just kind of make sure it works. Just kind of curious though, before I start out, we had this conversation earlier. Would you rather eat a baby goat or a matter baby? Baby goat or a matter baby? Oh, what's that you're asking? What's the matter, baby? Nothing much, ECEG 100. I hope y'all are doing fine this wonderful evening. Let's do some AC simulation. So, what we want to do an AC simulation, we want to take our circuit. I'm going to hit stop because it's simulating right now. Take our circuit and we want to replace the DC supply with an AC supply. So I'm going to get rid of our DC's input value. Go ahead and get rid of that input. And I'm going to replace that now with an AC source. So what we essentially want to do is have a sine wave that goes in and a big sine wave out. Because that's really, when you think about amplifiers, one of the most common things would be something like guitar amps or audio amplifiers. That's where it comes in. But really, any sort of signal is what we can amplify. So let's draw this. So in other words, we have our system is going to look like little bitty sine wave in. That's going to go into our inverting amplifier circuit and all the stuff around that. And then that becomes big sine wave out, and that gain would be, right now, it'd be -10. So in terms of a sine wave, the cool thing about when you're dealing with audio or sine waves, something like that, is that, well, you just really are flipping it around the axis. It's equivalent to 180 degrees phase shift. You're just really changing. So instead of, if your peak right now is at that part, well, then that becomes then a negative peak. And that's really all that means for a negative amplifier. But we do have, you can think of it as a phase change, or you can really just think of it as that we're inverting the value. For AC signals, it's not as big of a deal as you might think. So back to Multisim. What we got? Gonna add an AC source. So click sources, AC voltage. Gonna go ahead and connect that to our ground. Wire it up here to the existing circuit we had. Where'd you go? Wire, there it is. So if I click this, the amplitude 1 volt, yeah, that works. Frequency 1 kilohertz, that works. And we don't want a DC offset voltage. That seems all fine to me. Let's go ahead and add a voltage probe. Click that here. And now when I click run, let's see what happens. All right, it's running. Now, what you see, I think a lot of you had this happening. If you look, the numbers are doing this. Please don't screenshot that. They're doing crazy. The numbers are all over the place because you have a sine wave that's going doodly 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 doo, and every once in a while the simulator is like looking at that, picking the value, and then displaying it over there. And that's hard to do because it's jumping around between 0 up to, what do we set to be, 1 volt, down to 0, down to -1 volt, and back. It keeps oscillating, and we can't quite pick the values consistently every time. Likewise, our output is just jumping all over the place. So your engineering intuition should have said, this is not the right way to do that, and you are correct. So we need to add a way to display that. And if you look at Multisim, at the top, there's these 3 things. We have schematic, grapher, and split. If you click grapher, it'll show you the graphs you have. So we have a blue and a green thing. What are those? Let's go back to schematic. We have a green is our input. Blue is our output. If we split the window, well, we can conveniently see both. So in the graph, that doesn't look good. Let's see. I click graph, and this is my info window over here. We need to get this to where it looks a little better. Is there any way to do that? Let's just show our output. Yeah, that's way too big. Let's see if we can stop this and restart, if it'll scale it for us. Nope. So trigger is okay. Source PR2, the green. Yep. There, I clicked the voltage button and it auto scaled it. See that? So what you can see, this green signal is going up to about, I don't know, 1 volt. And our output is going up to 10 volts. So this clearly shows that we have generated a amplifier that can scale by a factor of 10, and it's inverting. So you can see when this is going high, our peak's high, our output signal is peaking low. So you can't quite see the curves. You kind of see where I'm looking at. So anyway, this is working and showing the whole schematic working. So this is the view that you want to show to prove that you can go above. Now, the other thing you might see is that let's say that instead of having 1 volt, I'm over here clicking the voltage source. Let's say we had 2 volts. Now, gain of -10, so we should let's go to 20. Get 2 and hit enter. Let's see what happens. Oh, did you see that? Okay, starts to look weird. Let's go up to 4 volts. This is again the input voltage. Well, yes, it's using significant energy, old Mac. Hit 4 volts. Now we expect this to go from -40 to +40 volts on the output, and it's not going to be able to do that. So we can see it starts becoming more like a square. That's what I was wanting you to view on your multisim simulation. So let's go back to 1 volt because our input range matters. The other thing you might have run into, and this could be a problem, is if you look at the frequency. Right now it's at 1 1 kilohertz. If we start increasing that and go up to 10, well, that's hard to see. Can we zoom in a little bit? Let's just stop and restart that. No. We'll just change it manually. Sorry, that's still working fine. Let's go back. 10 kilohertz. I think so. Yeah, this 100 kilohertz. Click our graph. Let's go back here and scroll. Aha, so it's there. We'll start to see a problem. This does not look at all like what we would expect. So somewhere between 10 and 100. So let's just do 50 kilohertz. We can still kind of see the same thing. So what's going on is that the op amp is trying its best to output. Pause this. The op amp is trying its best to output, and it's working to output the signal, but just can't quite do it in the time it has. So that causes the output to just start to not look like a sine wave. So if this happens to change your frequency down, let's go back to 10 hertz. That's pretty slow, but should definitely will do that. And then you're going to click graph, scroll down, change your scale. Whoop, too much. There we go. We're back into business. So the two problems you could run into are that the input amplitude of your AC wave is just way too high, so that your output is just railing against the rails of the power supply, and so it starts looking like this square wave. That's not good. The other way is we might be having too high a frequency, and that is causing some problems. And then the third thing is if you're not looking at this time domain grapher that we have, you're just going to see random numbers the entire time and get no meaningful data. So I hope that helped everything. I think that might help you explain a few things that tended to be what I was getting problems with. You saw me create an amplifier. I made an inverting. You have to make the totally different non-inverting amplifier. You are constrained to the resistor values that you can use. You have to do it choosing resistor values that we would get from that E12 series. So do some fancy combinations to get the numbers you need. But show me some screenshot like what you just saw. So what we just had was this with seeing the plots going at the same time, input and output. And that will work for that. So hope that works. In terms of due dates, I'll post an announcement about that. You can post a little bit later. But get this done and talk to some Piats if you have questions. Thank you very much. I will see y'all. I don't know when I'll see you, but I'll see you on video soon. Goodbye.